In this segment, we're going to take a look at Section 2, Problem 1. In this problem, you're given information about Roadhouse Ribs. They are the only employer of food service workers in Thatcher, Idaho. That should tell you immediately, since they're the only employer, there's probably going to be some friction in this marketplace. And specifically, that friction will be seen through mobility and will be some form of monopsony. We're told that the output price for ribs, or P, is equal to 3. We're given a labor supply relation of LS equals negative 10 plus 4W. That we are not given a labor demand relation also is indicative of some friction or some monopsony in this market, just as you've seen in some of the review problems and such as you've done. And then you're told that Roadhouse Ribs is a profit maximizing firm in a competitive goods market. Not necessarily a competitive labor market, but a competitive goods market, which is part of why you know that the output price for ribs will remain constant. So here you're given information about W, which is the variable W or wage perhaps in the labor supply equation. You're given values for Q. Remember that Q is the quantity of the output good. And you're responsible then to identify labor supply, marginal product of labor, price, marginal revenue product of labor, total cost of labor, and marginal expense of labor. We begin this by identifying the labor supply values. We know that we have the labor supply equation, and so we simply will substitute for W these values of W to get new values of LS, which in this case will be 2, 6, 10, 14, and so on. You've noticed here that a 1 unit change in wage is begetting a 4 unit change in labor. So once you've seen that pattern develop, if you have a linear labor supply curve or labor demand curve, where there's a different type of problem, and you have a constant change in wage, 1 unit each time, you then are going to have a constant change in labor supply. So once you've identified that it's a 4 unit difference, you go from 2 to 6 to 10, and then very quickly 14, 18, 22, blah, 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 all the way down to 46. Recall that the marginal product of labor is a change in quantity of the output good, divided by a change in labor. So we don't know what they've changed from to get to this first row. Oh, you might have surmised that W was 2, which means that LS is, well, negative 2. So we don't have a quantity. You don't know what the quantity was even because you're guessing at that. So you can't come up with a marginal product of labor there. But for the next line, where W is 4, we know that the change in quantity is 38. The change in labor is 4. 38 divided by 4 is 9.5. And so we run that exact same metric all the way down, and you notice it is decreasing. Well, that shouldn't surprise us. We know that as we have greater number of workers, the marginal product of labor declines. Our price, P, is constant at 3. That's the constant price for ribs in a competitive goods market. And so marginal revenue product of labor is marginal product of labor times price. We don't know what it is in the first row because we have no MP of L, but we have 9.5 times 3 equals 28.5, and so on, all the way down to 4.5 times 3 is 12.5. To get the total cost of labor, that's the wage times labor. So W times L is total cost of L. And so we got 6, 24, 50, 84, and so on, down to 64, which, by the way, is changing. We don't see a constant change necessarily between those. And then finally, the marginal expense of labor is the total cost of labor, or change in the total cost of labor, divided by the change in labor. So we have a constant change in labor, but we don't have a constant change in total cost of labor, so we don't have a constant marginal expense of labor. By the way, that should be the final clue to you that we have a friction market here or a monopsony market here. So these are the values you should have ended up with. By and large, those of you that tackled this question, which is most of the class, did this part very well. So to the second part of this, I ask, how might you label the type of producer this firm represents in the global market? What's the most likely factor? Well, as I've said now a couple of times, this is a market in some sort of friction, and that friction should be clear to you that it's a monopsony. There's one employer of labor in this market for this type of labor. That is a monopsony. And you learned through the various modules that you studied and such that the most likely cause of monopsony is some level of mobility cost. Otherwise, people would move from that market to another one to find a job. So the cost of relocation must be greater than any wage difference they could get by relocating. So some of you pegged this, some of you did not. I had some fairly interesting responses to this that were totally irrelevant, but I had most of these responses were pretty accurate. And then in part C here, how many workers would you hire for this firm and how much would you pay each worker? Well, I'm saying you're going to hire 30 workers and you're going to pay them 10 each. So let's see why I would say that. We're looking for a relationship between marginal revenue product of labor and marginal expense of labor. Because remember that our profit maximizing point is MRP of L being equal to ME of L. Okay? So where are they similar? Well, we know when W is 4 that we go from MRP of L to ME of L much lower. And then down to the next row it's lower, 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 lower. Where are we going here? Well, it's still at $9 wage is still, we have MRP of L higher than ME of L, and at $10 is still higher than ME of L. But then when we go to $11, then MRP of L is less than ME of L. So we want to stop at $10 per hour and 30 workers. $10 and 30 workers. If we move to $11 and 34 workers, then we know that the revenue product of labor is less than the expense of labor, marginalities of course, and we don't want that. We don't need to design our opportunity to lose money. There are plenty of other ways that might happen. Let's not design it. So we're going to stop short here at 30 workers at $10 wage. Now you might say, well, why isn't it 10.5 or 10.25? And the answer is because you don't know what the changes are here in quantities as you move from 30 to 34. You know it's 524 to 548, but what about when you move from 30 to 32? You don't know that you split that difference. You would be making a guess there, and you've been instructed on these to not make that kind of a guess. So you would have 30 workers at $10 an hour. And then I say, how much, so the next part then is let's go ahead and label a graph here. Let's give a properly properly articulated graph here showing LS, ME of L, and MRP of L for this. By and large, this was done fairly well. Students missed points on this by not properly labeling things. Some students had 2 downward sloping curves instead of just the one marginal revenue product of labor curve. Some students had marginal expense of labor below labor supply. You've never seen that. Some students didn't give any values. So when you look at your exam and compare it to the image that you're looking at here, you'll see somewhere where you probably lost some value here. And those were important. What we're really thinking about here is at the point where marginal expense of labor equals marginal revenue product of labor, which we don't actually quite get to, we then look at the MRP of L and we look at the ME of L, which should be equal. They certainly are at that point, but they're not at these points. But more importantly to us, we know that that's the point we're going to stop at, and that gave us 30 workers. And at 30 workers, when we interact that with the labor supply equation, that told us that we are going to pay each of them $10 per.